The universe will not end in a single explosion. There may be no final collision, no enormous fireball, and no single moment when everything suddenly disappears. Instead, the death of the universe may happen very slowly. That trillions of years could pass between its final events. Stars will fade, galaxies will disappear from view. And even black holes, the darkest objects in existence, may eventually vanish. To understand how this could happen, we first need to look at what the universe is doing today. The universe is expanding. Distant galaxies are moving away from one another because the space between them is growing. But this expansion is not slowing down. It is accelerating. Scientists believe this acceleration may be caused by something called dark energy. We still do not fully understand what dark energy is, but if it continues behaving as it does today, the universe may keep expanding forever. At first, the changes will be almost impossible to notice. Stars will continue to shine, new planets will still form, and galaxies will continue to collide. But over extremely long periods of time, the expansion of space will begin to isolate the galaxies. The most distant galaxies will move farther and farther away. Their light will become stretched, weaker, and increasingly difficult to detect. Eventually, their light will no longer be able to reach us. The galaxies themselves will not be destroyed. They will simply pass beyond the cosmic horizon. A civilization living in the distant future may look into space and see only the stars inside its own local region. The wider universe, once filled with countless galaxies, may become completely invisible. But this will only be the beginning. Stars need fuel. They form when enormous clouds of cold gas collapse under gravity. Deep inside a star, hydrogen is fused into helium. This process releases the energy that produces heat and light. But the supply of gas inside galaxies is limited. Over time, more of it becomes trapped inside stars, planets, and dead stellar remains. Some gas is also heated or thrown out of galaxies, where it can no longer form new stars. Slowly, the universe will lose its ability to create new suns. The largest stars will disappear first. Massive blue stars shine with incredible brightness, but they consume their fuel very quickly. Some survive for only a few million years, before exploding as supernovae. Stars like our Sun live much longer, but they too will eventually run out of fuel. In about 5 billion years, the Sun will expand into a red giant. Later, it will release its outer layers into space, leaving behind a hot, dense core, known as a white dwarf. The longest living stars will be red dwarfs. These stars are smaller, cooler. They consume their fuel so slowly that some may continue shining for trillions of years. Long after stars like the Sun have disappeared, red dwarfs may remain as the final islands of light. Planets may continue orbiting them. Some worlds could remain warm enough for liquid water, and if life still exists in that distant future, these small red stars may become its final homes. But even red dwarfs cannot shine forever. Eventually, the final star will consume the last of its fuel. Its light will weaken. Its surface will grow dark, and after shining for far longer than the present age of the universe, it will finally fade away. The age of starlight will end. There will be no active stars, no bright galaxies, and no new sunlight. The universe will be filled with the remains of its past. White dwarfs will slowly release their remaining heat. Neutron stars will continue spinning in the darkness. Frozen planets will orbit dead stars, or drift alone through empty space. Brown dwarfs, Objects that were never massive enough to become true stars will remain cold and faint. White dwarfs will continue cooling for periods of time almost impossible to imagine. They may become black dwarfs. A black dwarf would be the cold, dark remains of a dead star. None exist today. The universe is simply not old enough. Even the oldest white dwarfs have not had enough time to cool completely. But, in the distant future, black dwarfs may become some of the most common objects in space. The galaxies themselves will also begin to fall apart. Dead stars and frozen planets will occasionally pass close to one another. Their gravity will slowly change their paths. Some objects will be thrown out of their galaxies and sent into intergalactic space. Others may gradually fall toward the enormous black holes, waiting at the centers of galaxies. Over unimaginable periods of time, the structures that once held billions of stars together will slowly dissolve. Eventually, black holes may become the largest objects left in the universe. For a very long time, scientists believed that black holes could survive forever. Nothing that crosses their event horizon can return. But quantum physics suggests that black holes may not be completely black. They may release an extremely weak form of energy, known as Hawking radiation. As a black hole releases this radiation, it slowly loses mass. For a stellar mass black hole, this process could take around 10 to the power of 67 years. The largest black holes may survive for around 10 to the power of 100 years, or even longer. These numbers are almost impossible to understand. The universe today is only about 13.8 billion years old. For most of their existence, these black holes would sit alone, inside an increasingly empty universe. But as a black hole loses mass, it becomes smaller and hotter. Its evaporation slowly accelerates. Near the end of its life, it may release its remaining energy in one final burst. Then, the black hole will disappear. When the final black hole is gone, the universe may enter its last and longest era. Only extremely weak radiation and low-energy particles may remain. They will continue moving through space. As the universe expands, the temperature of the cosmos will become incredibly cold and almost completely uniform. This possible ending is known as the heat death of the universe. Heat death does not mean that all energy disappears. Instead, energy becomes spread out so evenly that it can no longer produce meaningful change. Stars shine because their interiors are hotter than the space around them. Life survives because it uses energy flowing from one place to another, but without differences in temperature and without useful sources of energy. There can be no stars, no engines, and no complex processes. The universe may continue to exist. Space will remain. Particles may still travel across enormous distances, but almost nothing new will happen. There will be no new light, no new planets, and no new sources of warmth. Only an expanding darkness, becoming colder, quieter, and emptier. However, scientists cannot yet say with certainty that this is how the universe will end. Its final fate depends on the true nature of dark energy. If dark energy becomes stronger, the expansion of space could eventually tear apart galaxies, stars, planets, and perhaps even atoms. This possible ending is called the Big Rip. If dark energy weakens, the expansion of the universe could slow down. Gravity might one day pull everything back together. In a catastrophic collapse known as the Big Crunch. For now, none of these possibilities has been confirmed. The universe still holds many secrets, but according to our current understanding, its most likely ending may not be violent. It may be almost completely silent. Galaxies will pass beyond the horizon. The birth of stars will end. The final red dwarfs will slowly fade, and black holes will lose their mass before disappearing into the darkness.